What is differentiation? Differentiation is a fundamental concept in calculus dealing with a rate at which a quantity changes. It is the process of finding the derivative of a function, which provide information about the slope of the function at any given point. Technique of differentiation. First, we have a trigonometry rule for differentiating sine, cos, tangent, and another of trigonometry function. And second, we have a generalized power rule, any extension of the power rule when the base is a function. And the third one, we have a exponential rule for the differentiation the exponential function. And the fourth, we have a logarithm rules for the differentiation the logarithmic function. So if we continue, we have a product rule, we have a chain rule, we have a quantum rule, we have a power rule, and we have a constant rule. The product rule applied when a function are multiplied. Chain rule used when a function is inside the another function. The quantum rule is applied from one function is divided by another. The power rule used to differentiate the power of x. Constant rule is the differentiate of a constant is 0.
Assalamualaikum guys, my name is Aina and let's solve question number 2. Let's solve the question one by one.
Question A. Y equals to exponent to the power of x3 sine in bracket x squared plus 3 close bracket. First, we need to differentiate u. So u prime, we need to bring the 3 to the front, write the x back, and then we minus 3 minus 1 equals to 2. And then we wrote the exponent to the power of x3 back. Next, v prime, we differentiate sine into cos, and then we wrote everything in the bracket back, and then we differentiate x to the power of 2. So we bring 2 to the front, and then we wrote the x back. Shown here is a formula for product rules that we need to use to complete this question. It will be like this. Next, to simplify, we wrote 2x exponent to the power of x3, and then we wrote cos in bracket x squared plus 3 close bracket, and then we wrote 2x plus sine in bracket x squared plus 3. So we need to take the exponent to the power of x3 outside. Why? Because for the example, 5a plus 5b, the 5 is the same, so we can take the 5 out and leave the a plus b inside. So our final answer will become like this. Next, for b, y equals to x squared then 2x over 1 plus x cubed. In this question, we need to use quotient rules. However, we need to differentiate x squared then 2x first separately. So we will apply it to the product rules. U equals to P and V equals to Q. So to simplify, we bring 2 to the front, and then we will write 2x squared. Then we will change it into y equals to 2x squared secant square 2x plus 2x then 2x over 1 plus x cubed. So on the top, we will put u, and then on the bottom we will put v. Right now, we will use a quotient rule. We will just follow the quotient rules and it will be like this. So at the end, our answer will be like this.
Assalamualaikum and hi everyone. My name is Nani and we're moving on to question number 3. This is the question for question 3. What we need to do is we need to solve it using implicit differentiation. What we need to do first is we need to differentiate every equation. In this video, as you can see, I replace y with dy dx. Then we distribute every equation. And this is what I got. Next, we need to move the equation with dy dx to the front and without it to the back. After that, we factor out the dy dx. After we factor it, we move the equation at the front to the back. And this is the final answer for this equation. That's all for me. Bye.
Hi, my name is Khairul and I will answer the question 4. So the question is, use linear approximation to estimate the value of 3 square root of 64.02 minus 1 over 6 square root 64.02. So for the step 1, we need to define the function first. Let f sum x equal to x power of 1 over 6 minus x power negative 1 over 6. We want f sum 64.02. So we use linear approximation around a value close and easy. It is x equal to 64 because 64 equal to 2 power of 6. And then we move to the step 2. Find the known value at x equal to 64. Square root 6, 64 equal to 2. So f sum 64 equal to 2 minus 1 over 2 equal to 1.5. So after the step 2, we will move to the step 3. The step 3 is compute derivative f prime sum x. So we know the function is f sum x equal to x1 over 6 minus x negative 1 over 6 from the step 1. And then we differentiate it and we will get f prime sum x equal to 1 over 6x power of negative 5 over 6 minus sum negative 1 over 6x power of negative 7 over 6. Then we simplify it. Now we evaluate the equation we do at x equal to 64. So we know 64 1 over 6 is 2. So 64 power of negative 5 over 6 equal to 2 power of negative 5. And it is also same answer for the 1 over 32. Next one is 64 power of negative 7 over 6 equal to 2 power of negative 7, and if we simplify that, we will get 1 over 128, and then we put it back to the function. Then we will get f prime sum of 64 equal to 1 over 6 sum 1 over 32 plus 1 over 128. After that, we need to find the sum. So the sum is 1 over 32 plus 128. So it means it is equal to 4 over 128 plus 1 over 128, and we will get 5 over 128. Then we put it back to the function. After we put it in the function, we will get f prime sum of 64 equal to 1 over 6 dot 5 over 128 equal to 5 over 768. So after finish the step 3, we will move to the step 4. The step 4 is apply linear approximation. So the linear approximation formula is f sum 64.02 approx f sum 64 plus f prime sum 64 and sum 0.02. So we need to compute the change. The change is delta f equal to 5 over 768 times 0.02. And then we write it back. Delta f equal to 0.1 over 768 equal to 0.000130283. After got that answer, we will add to the best value. So we will get f sum 64.02 approx 1.5 plus 1.000130283 equal to 1.5001302083. And then the final answer need 4 decimal places, so we will write 1.5001. Thank you.